audios, I have a hesitation that whether that will come out well or not. Anyway, I rehearsed, I checked with the organizers and verified many of those, but still I am a little skeptical about that because I don't know how to operate many of these buttons and so on. I think that part could be, that's why what I did was, first I will finish my presentation uninterrupted. Uninterrupted means by the additional thing. And then toward the end, even after conclusion, I will start showing all the demos for about 15 to 20 minutes or half an hour and so on. So the demo, when I say demo, it's not just playing, I will also explain what it is about and so on. That is what I propose to do. And also another small thing you have to all bear with me. I am not expert like all of you in preparing a PowerPoint slide or demos and so on and so forth. So I may be switching several things because I struggle to make this PowerPoint like there is very few commands of this. And you have to bear with me with some of those things, you see. So generally, very rarely I use any PowerPoint slide or anything. I just talk, that's all. I never got used to the PowerPoint, but this time it cannot be helped. All right, so that much background is enough. And so I'm very happy to see at least about a dozen faces. And I only wish I could see all others as well. And please, and I am definitely, not that I am an expert in any of these things, but the point here is we can, by questions, we can discuss a few things. That's the point. And also this talk and title I have prepared in such a way that it is not just reading out some information kind of a thing. Hopefully, they just motivate you to look for how to, maybe that's a big term to use, but how to make a career out of this kind of a thing. What is it? What are the problems you should look at? How to look at a problem from my perspective, you see? And which are at variance from what many people think and so on. So everything you have to take with your own a pinch of salt. Maybe if you don't agree with my view, it's fine. But so what it's also so happens that I have been in the teaching profession for now maybe 55 years or plus. I was a faculty member in 1966. So you can imagine. So the reason I am quoting that is, so my talk, my presentation, my views, everything reflects that part of it. So some of it may not be right or you may not agree, that's fine. You see? So it is not just what I read in the last few years or something like that. Okay. Now let me start with this simple thing. We just finished Tokyo Olympics. See, and there is the most important event in the Olympics is, for example, 100 meters. You see, and isn't it? That is the fastest. In fact, Olympics started with that. Later on, all of this. So in 100 meters, the fastest record breaking and so on, they'll say 9.9. Let us not worry about it. Let us put a round figure of 10 seconds. So 10 seconds in 100 meters. You see, and that is what. So if the same person were to, run for 1,000 meters, please follow my question carefully because this is the take-home message at the end of the talk also. If the same person has to run for 1,000 meters, how much time will it require? You get the question? I want you to get the question. I say, if somebody wants to quickly respond, it's fine. Otherwise also, just I will put several such questions later during my talk, but this is a very important question, you see. And so what it can be, anyway, I will not have time to elicit your response to that. The answer is, after all, you can't multiply 10 into 10 and make it as 100 seconds you will go 1 kilometer or 1,000 meters, isn't it? All of you agree with me or not? You agree with me? What it simply means is you cannot project the result of some experiment or result of something to some other scale blindly. That is the point I want to make here. And deep learning is no exception. That is the take-home message of. We'll see why I'm saying that and so on. You understand my point? I am saying why I brought in that. So just because somebody could run 100 meters in 10 seconds, you can't say 1,000 meters he will do in 100 seconds and 10,000 meters he will do in 1,000 seconds and so on. You can't extrapolate. You get the point there? So again, now come back to the following point. This topic I have chosen is deep learning based, speech separation. That's what I said. So now the question here is, let us start from the beginning of this speech. In 1955, most of you may know, the term artificial intelligence. It was introduced in 1955 by John McCarthy. Suppose all of you. That's where the term itself has come, artificial intelligence, you see. And so what are the purpose there? The purpose was that the idea or objective of that workshop was, in fact, the chairman laid out the scope of that workshop. He said, what do we understand as human beings? You see, if our understanding, can we simulate it and show? Please take my word very carefully, because whatever is given to, I will show you a lot of what is being said these days. So our understanding of the human way of being, call it intelligence, can we simulate it? Or that is the that too he calls it a test. Notice, never said that build a machine and so on. Our understanding, the key there is understanding of artificial intelligence to simulate. See? That was in 1955. In 1957, I don't know how many of you have heard, Colin Cherry, he wrote a small article and he introduced a problem called cocktail party effect. Cocktail party effect. I don't know how many of you heard that name. Anybody can just raise your hand if you have heard that name, cocktail party effect. Oh, very good, very good. Anyway, for others, you see, the problem for discussion I have chosen is that one only. See, but what is a cocktail party effect? If we go to a party, let us say, party or any group discussion, and then we meet a lot of people and so on, and then the surprising thing is, in spite of the fact that so many people are talking to you and somebody talks across like this, from left side, right side, and we are talking straight and so on. Or you skip the fellow in front of you and talk to the fellow behind you. You see, that is beautiful, you see. And Colin Cherry made a statement that human beings are so good at capturing the message of the speech. Notice, I try my best to use the words very carefully, because I know that my students and even other faculty and youngsters and so on, they are a little casual in using the words. Even I may be, but I try my best to be careful. So what I am trying to say, they are able to capture the message through speech of the speaker that he wants to, in spite of the other environmental noise, other speech and so on. That is called cocktail party effect. And the question that was asked is, how is it that human being is able to do? And of course, the question, just as artificial intelligence, can we display that or can we simulate that intelligent behavior of a human being called intelligence and a machine, simulate? And likewise, can you realize this by a machine or whatever it is, system and so on? Basically, what it means is it's not a question of realizing. Those days, there's nothing like realizing. Can you understand what that means? How is it that a human being is able to do cocktail party effect? Follow what I'm saying? So this is what was proposed. AI and term was introduced in 55, and cocktail party effect, which is nothing but a human way of understanding speech of other person in the midst of other in the environment of a party, and it has a speech separation. That is the word we have used. A speech separation which includes speech and speaker as well. And so how is it that a person is able to do it? Can you ever understand that? If you understand it, at least to some extent, you may be able to simulate it and so on. Notice it is never to solve a problem, never to build an intelligent machine in AI, never to solve this problem, but you're only displaying your understanding through something like a simulation. That was called a cocktail party effect. And even today, the problem remains, although I will show you toward the end of my talk, a lot of groups are claiming that we are close to a solution. The answer is it's like a mirage, you see. You will not see a solution. And the whole purpose of my talk is to show why it is so. I say, why it is so with all the development that I notice. What was AI at that time? Now it is all, I'll come to the details of this, it is all deep learning. And whatever you're doing with the deep learning, by now, since you are exposed to so many lectures, you know better about deep learning much better than me. So I'm only using the term. Now, deep learning, whatever you're doing with the deep learning, please note again, you call it AI. It is not that you want to understand intelligence and simulate it or do something, but whatever you are doing with what you have, like DL or DNN, you call it as AI. You can see how this had, why it had changed also, I will come to that. You see? So you have DL as a tool for AI, and and you have the problem. That is the cocktail party problem. So you want to apply the DL to the cocktail party problem and solve that. That means what solve is a loose word, but anyway, it's okay. Basically, what he means, they say, can you separate the voice from that crowd that you pick up, put a microphone and pick data? And can you separate the voice of your desired target voice from the rest of the that is and they say the deep learning can do that. That is the reason why I have chosen the topic here. See? So, and so again, so the whole objective of this my talk is to just understand these two and where we stand right now, kind of. See, that is what I suppose up to this part it is clear. It is just be careful. This kind of this direction of introduction is not there, so you cannot just refer to a book or something. And also for the same reason, you cannot also take it for granted that whatever I said is the right one or perfect one. No, I want you to think in your own way. Okay. Now we were through this talk. What we will discuss is what is that DL? Why did we arrive at that? And what is the problem in the first place, cocktail party problem? How is it that this can solve, people are excited about solving the problem using this tool and so on and so forth? You see? And is it that everything is in a few years or a few attempts by a few groups can solve the problem? That's what. Actually, like everything else in a natural task, which of course I don't have time to explain, everything else in a natural task, you see, the more you probe, the less you know. This is true with physics, this is true with chemistry, this is true with any natural thing, not synthetic. Anything in nature, if you see, the more you probe, that is why you can see doctors, biologists, neuroscience, all these people, they struggle. You see, externally, all of us seem to know something about neuroscience because we don't know inside what is happening. The moment you start probing and trying to understand, you're lost. You see, we don't even understand how a biological neuron works, although at least 3 or 4 Nobel Prizes have come with their limited understanding that it is displayed by biologists and neuroscientists and so on. So, and it is impossible to understand. And that is the nature of a natural system, So speech is nothing but one of those natural things. So I suppose I spent a lot of time so that this, I suppose this message I want, with this background only, you will be able to appreciate what I will be talking about, kind of a thing. So, no, you see, I suppose all of you can see my slide. I will be flipping my slides a little bit, that is and also I'll minimizing your view, seeing you. So all of you can see my full slide. Is there any problem in that? Okay, so now speech, the title I have chosen is speech and speaker separation using deep learning. You see, and you also please understand, as I'm an old timer.
Excuse me, sir. Sir, your first slide is visible.
First slide. I am only talking about first slide.
Yes, sir. You are on first slide.
I am only on first slide still. Okay.
Okay. Okay, sir.
Okay. So please note that I had chosen this topic. I already told you the background why I am choosing kind of a thing. You see, and actually my research and initial work in 60s and 70s was mostly physics based. You see, and so you can say science. Then I did some engineering, and by the time I have to do some technology, I retired. So I am now depending on others to help me in the technology and so on. So that is my background. So I have chosen this topic only to show you what nice things that have happened in this technology development. So I use technology and deep learning interchangeably in this context. And the speech and speaker separation. I have briefly explained cocktail party effect. If you probe a little more carefully, although if you read papers, everybody says we are reaching a solution kind of a thing. But if you probe a little bit, you will see you will never be able to reach a solution. By more experiments that you do, that is because you didn't understand the problem. You are twisting the problem to say that you are likely to reach or you reach a solution or things like that. And that is what I want to explain in the next slide. And can you see my second slide? This slide, please. Second slide, outline.
Yes, sir.
Okay, good. All right. So let us see. This is quickly an outline. Now I can go through in a few seconds, and then so I will try to explain what is speech and speaker separation problem. Again, I mentioned with reference to a cocktail party type of a thing. Note that cocktail party type of a problem can never be generated by a synthetic means. Please understand, you cannot generate a synthetic cocktail party problem. You see, please very careful. I will tell you why. In fact, again, my goal here in all of this is I am expecting most of you have some interest in research, if not in this field, how to think and how to evaluate what is being done by even the top, so-called top researchers, top in the on paper at least, you see. And so you should not assume that just because he is a top researcher, he knows everything, what he did is correct. In fact, if I ask me, most of the papers, most of the things that are there, they have big gaps or holes in it, you see. And the people try to hide them rather than highlight them, you see. That is where the problem is. A good research is one where you should highlight. But most researchers, for want of avoiding criticism and also for publishing, you hide them. You see, that's exactly I am going to. So, what is speech and speaker separation problem? As formulated by many of the studies that are made, the idea is if you have a mixed signal like that, if you have, as I told you, like in a cocktail party problem, that means if 3 or 4 people are speaking or somebody is speaking in a live room environment where there's a lot of noise and the reverberation through the reflections in the walls and so on, the goal here is, if it is can you pull out the speech, let us say speech plus noise is there, can you pull out the speech part of it irrespective of what the background noise is? You see, because you can't decide on the background noise. If you go to some other place, background noise will be different. So you can't rely on that. What you can rely is only on speech. That part is not highlighted in, although it is not highlighted in almost all the research that is being done. Please note that. Because this whole conference is about speech processing. That's why I'm highlighting that part of it. And what is speaker separation? Speaker separation is a subset of this problem. That means if speech plus noise is there, pulling out speech. Or speech plus speakers, other speakers sound is there, again pulling out this desired speaker. So both are speech separation problems, you see. And in one case, you are pulling out the desired speech in the midst of background noise. In another case, in the midst of other speakers' voice, or both. A practical situation, you have both speakers and noise and so on. And you can see human being. Fortunately, we didn't design our system. And the only every time in my class also I raise my hand like this because God only knows kind of a thing. See? Because we don't know how it is. We just so human difference for this. You see, why this problem? Because we are able to do that effortlessly rather, and we are not able to explain. The question, intellectual curiosity of an engineer or a scientist or a technologist in particular, is that when we can do it, can we make a machine do it? That is the question. So that's what I'm going to discuss in the next slide, human reference and so on. And then, of course, some of the other things up. And when you, I will not go through one by one. There are several approaches that have evolved for solving this problem. First, by diluting the problem. That means you collect the data in a little confined environment. In fact, many of the studies that are made, you don't even collect. You simply simulate that situation. You take 2 or 3 speakers speech and then combine them. Or you take the noise and speech and combine them. You see, that is the kind of audio simulated interpretation and convolve with the speech signal. That is what is being done. And very rarely it is taken in from a practical environment. You see, and this is very important. So I will, we will approach it avoid over a period of time. And especially myself and my group with my students, we started looking at not as a cocktail party problem, but as a general speech mixing problem, how it is. At least half a dozen of my PhD students got degree, but they never used the deep learning and so on. But now deep learning is making a big headlines, and it is fantastic also. It is doing a lot of interesting developments, which we briefly discussed, because you should also know that I am not an expert in application of deep learning. I know what it is, but I am not expert in application of deep learning or anything. By the time all the developments came, I retired. And so, so discussion of different approaches, how it evolved. As an engineer, as a scientist, as a researcher, never look at a task or a tool or a paper or a method in isolation. Always try to find out its history and also the masked or embedded limitations and so on. If something, in fact, as a researcher, I used to tell, I have no interest if something works. I have no interest in something works. You see, then everybody is working. What is the point? That's why. So, and then the most important thing is what led to the deep learning approach, based approach. So this is the one I may spend about 5 minutes on the 5-10 minutes on this. That is evolution of, we started with AI, and now whatever we are doing with DL, we call it AI. So how did we reach this point? See, some of you may know, but I'm assuming that most of you may not know. That is the way I know. So that's why I would like to repeat that. And then discuss about 5-10 minutes, not a whole lot. Deep learning methods, as I told you, I never directly worked on this, although I read some papers and so on. And I borrowed somebody else's results here to just display a few of them, in none of them, but a very active group doing fantastic job, you see. And the only thing you have to be careful, at least younger, if some of you are 50, 60 years old, then my talk would have been slightly different, you see. And because I said, don't even worry about it, kind of a thing. And if some of you are only, let us say, undergraduate students, again, my talk will be different, you see, because I don't even talk like this to them. Since you are active, you have to make a career. Don't believe any of them on their face value. But fantastic advances. I will tell you what I mean. And then, of course, I will also tell you some illustrations of different approaches to the extent possible. And most important is comments and conclude. This is my layout of my talk. And now I will, this is very easy. I have already mentioned. Just to many times the most difficult part is how to define a problem. You see, all of you may already got a PhD, or you are looking for PhDs and so on. the first thing we will ask if you are working for a PhD, what is the problem I should work on? And if I am a supervisor and if I know what is the problem, then I don't need you, I can do it myself. Identifying a problem itself, clearly defining is a 50 to 80% or 60% of the problem is solved. You see? So now, like that, here the different situations we are talking about, speech collected in a non-speech environment. Please note the speech collected in a non-speech environment. That is what I meant as a noise, reverberation, and yeah, anything similar to that, other than, of course, other speech. That is one type of it. Because why I am mentioning is the most of the current research is being done, all of this in isolation. And most of the current research is being done, all of this, by simulating most of the cases. Simulating. Of course, there are a few cases, their natural data they taken. And so, first of all, is speech collected in non-speech environment, I suppose by now you understand, which includes noise, reverberation. Reverberation is a most difficult thing for to develop algorithms. Because whereas it is interesting as a human being, you will love to have some reverberation. In fact, that's why a place where you have some reverberation is called the live room. A live room. If you don't have a reverberation, it's called a dead room. You see? And in fact, I built one of those so-called dead rooms in a crack chamber in about 55 years ago. And it took 5 years for me to build. And there you go inside, you can't hear anything outside, anything happening. The only thing is, if you stay long enough there, about 5-10 minutes, you start hearing a lot of noise coming from the molecules vibrating in front of your eardrum. You see, that is the kind of, that's what I meant as a dead room. You see, and you don't want that. You don't want to live. In fact, you will go mad if you stay there for, although I did a lot of experiments in that 50 years ago. So, so noise and reverberation. In fact, why I'm saying a lot of deep neural network methods are developed for reverberant speech. How to, but a human being, that live, of course, if it is too reverberant, it is but normal live rooms, human being wants that. That's called the term, because my initial research 50 years ago was on acoustics, room acoustics. That having that liveness is called acoustic warmth. Acoustic warmth. See? Anyway, I learned. So the second type of a speech data that you collect for this operation is collect an environment consisting of other speakers. You see, 4 or 5 of you friends get together and start talking to each other, kind of a thing. You see, it's not that one talks to the other. Even in Parliament, we don't talk individually. Everybody talks together. So what to talk of in friends, obviously it is same. You see, so the question here is, how do you separate the speech of individual from that? That is the second problem. And third is a more practical. These are two still constrained environments. More practical problem is you have both. See, how do you separate? There are many more things you can. So if you have a speech like that, what could be the task? Defining the clarity is important. The task could be to separate or isolate, you see, the target or derived speaker speech from the mixed signal. This signal that you collect, I call it as a mixed signal. Or the task is to detect the presence of or absence of. Suppose you are given a sound recorded in such an environment, and you are asked to find out if a particular individual speaker is there or not, just by human listening. That is the first. But then, of course, you want to do it automatically by developing an algorithm. So, I'm not interested in extracting the speech. I'm only interested in detecting whether some speech or some sound is there or not. In fact, you will be surprised to know, I didn't have time to go through it. Otherwise, my talk would have been very different. I just got the issue only just 2 days back. By then, I already collected my thought. There is a sound event detection. I'm giving some reference toward the end of my talk. That was the first reference, which is published in IEEE Signal Processing Magazine, September 2021. Excellent article. Okay. Again, I didn't read, but even then I am saying excellent because I browsed through it, and in fact that should convey many of my points which I am mentioning, and of course some things which I have not read, so I cannot comment, but I may not agree with them, but that motivates you to really probe and find out what it is. Okay? So the task could be detect the presence of or absence of a target, speech. And the third one, I am mentioning speech. It could be some other sound because this is a course on deep learning, speech processing using deep learning. So, our the task should be enhance the target speech if present in the signal. That means, suppose I have a mixed signal like this, and I know that you are also speaking in that. I want to know whether there is an algorithm by means of which I can enhance. I'm not interested in separating. I'm interested in enhancing that so that more attention can be paid and you can find out what it is. So you see, but you see, these are, and there are many other tasks like this you can put. You see, but these are more practical way of defining a task rather than the kind of a task that are being addressed in most of the research papers now. You see, what is the kind of task that they want to separate the speech from the, they also show that they can separate. But of course, it's a lot of question marks, but they do a fantastic job. There's no question about it. I will show you some demos on that. See? So it is not separating the speech signal. That's what we, so you can give that. In fact, what happens, next slide will tell you, what happens is, if you start extracting, just don't worry about the slide. First, you look at me. The most important thing when you are listening to some such practical speech in an environment is the following: that you try to get the message part of it. You get a few sounds or hints and so on. Rest of it, you fill it up from here. That is a human way of doing it. In fact, you will never separate the speech. Human being never separates the speech. You see? On the other hand, if you start by means of some of the current algorithms, let us say people might succeed in extracting the speech out of that mixed signal, you'll be shocked to hear that you cannot even understand the speech. Again, you can see my talk is just motivated for you to think. Did you understand what I'm saying? If I am able to collect that speech in an environment like that, if I can enhance that is good, or if I can, the moment I separate, you have a problem. Many times it is not understood at all. Understood means at least it is highly degraded. What is? Did it ever occur to us that's what happens? In fact, that is a fact. You see? And the more so, the problem posing itself, that speech separation from mixed signal, because the artificial mix and separated is a different issue. In fact, it is also interesting, all of us we attend music concerts, let us say, the vocal musician, one or two, and all other violin and veena, everybody is there, and we enjoy that, you see. And one of the challenging problems with IEEE special signal processing special issue on music information retrieval. Very beautiful article. You see? And so one of the things, at least, again, I'm not saying that all of them, but it poses a lot of questions rather than answers. You see? One of the interesting things here is, suppose you have a concert like that and you want to separate individual vocal music and instrument music separately. You see? It will sound awful. See? Awful means, again, when I say awful, please take it with a pinch of salt. Basically, what it means is it is not as pleasant as you hear it in a concert. That's what I meant. You see? I use sometimes the extreme words to emphasize my point. Otherwise, don't take it literally. Okay? So, you understand my point? In fact, why? In fact, I heard a talk by a music artist, a very famous music in Tamil Nadu, and long back, she had a PhD in music, apart from an excellent vocal musician and so on. She explained what it is. You see, the accompaniments are meant also in addition to smoothen some of the deficiencies that the vocal artist has. You see? And if you try to separate it, you are in trouble. You get the point I'm saying? I think this is very interesting. So again, the point I'm trying to make here is that if you take a cocktail party effect like thing and then separate, you will have a problem in this whole thing. On the other hand, you artificially take your voice, my voice, and some instrument voice, mix them and separate. All of them sound nice because individually they are good. You see? So that is the, so understand the, so the, another very interesting, this you have experienced. You see, I'm sure most of the advertisements on TV, of course, your people are good, but this audio video based advertisements, 90% or even more of those advertisements, I never understood what that advertisement was about. See. Surprisingly, sometimes what happens is that video goes off. See, then you can make out what the message, what the advertisement is about. Okay, there, both the audio and video are not taken simultaneously. They are added. They are added. In fact, a lot of advertisement managers, designers, they don't even know the damage they are doing to the advertisement. But of course, maybe they are making a lot of money. That's a different matter. That's it. The point here is the audio part of it is more acceptable. Or in fact, you can make out the message if video is not there. If audio video is there, most of the time message is masked. See? And it's not only me, I think it's the experience with all of us and so on. So audio, so I already mentioned cocktail part effect, audio, video, advertisement part, music, concert and so on. And as I told you already, I already mentioned this, rarely a person extracts the signal. He gets the message, he doesn't extract the signal because he cannot also extract. And of course, there are lots of illustrations to say. There is a scientist, Franklin S. Cooper. He said almost 45 years ago, there is an article in Journal of Coastal Society of America. He was saying that when you are listening to, in fact, even when you are listening to me like this, please note that you are not taking all the sounds that I am uttering. The moment you make an attempt to understand every sound that I am uttering, you cannot get the message. So the beautiful part here is, when you listen to me, it is only a acoustic events, a few acoustic events you perceive, and then rest of it, maybe 90% of it you make up from the what is already available. All right. This is true even for you people who are specializing in, say, neural network speech and so on. It is true. What to talk of somebody else who is not. So if you are understanding that is because you are taking only a few, if you ever make an attempt to understand every sound, it is guaranteed that you will not get the message. Is it? That is the beautiful part of it, you see. And so what do you mean? And another interesting thing is, that part, if it is universal, you get each one of you get the same acoustic ends, and if you are able to articulate the end, then also the problem is tractable by an algorithm or a machine. Unfortunately, the acoustic hints so that each one of you will get will be different. Different depending on your background, your exposure, your this one, your interest, all of them will dictate what you should capture and so on. So why I'm saying all of this is, so the problem as posed, even including deep learning models and so on, are faulty. The problem posing itself is a problem. Not that in fact, excellent results have come, but when you come to the practice, in fact, how can you separate the speech and say that this is the separated speech, it should be better, when it is not even produced in the first place? That clearly, isn't it? You see the point I'm saying? So this is a great research problem. This means it's not this derived, at least 100 research problems can be brought out of it. You see? A lot of people worry about what research to do and so on. If anybody comes, I can say anything you take, especially in the area which Everything is a research problem. I can easily list 100 research problems. No wanting for solutions. You see? Anyway, so that is it. Hence, now, because of this, extracted speech may be unnatural due to that is called a lumbar defect, although it is a much more specific or similar defect. What is a lumbar defect? I don't know. Has anybody heard about it? Lumbar defect? Anybody? No.
Yes, sir.
Oh, good. So what is lumbar defect? Basically, what it means is you put yourself in a noisy environment or you feed through a headphone some noise and then you are asked to speak. You see, surprisingly, your voice is not natural voice. You see, so because that disturbs that environment is so here also in a party, that's exactly what it is. You don't have to feed through headphone. So the separation of source and remixing of practical mixtures may not be useful in this, and also it is unnatural due to lumbar defect and so on. And also, so all the evaluations that are being currently done, almost 100% of the paper, I may be wrong in one or two, all the result, signals and the data for the TAR and made evaluation using evaluation measure are on synthetically mixed signals. If they are, they're not realistic, so they're not useful. They're not useful. You see? So you can see this is why this discussion came. It is because ultimately we are processing speech for a human reference. You are able to produce speech, you are able to pursue speech. That is the reason. You see? And this is what I coined. So it is not universal. So a lot of things can be debated on this. So this is why is all these things and many more things that are happening because our biological neural network, BNN means biological neural network architecture, is a dynamically reconfigurable architecture. It's a dynamically what it means is, although you say there is a DNN, there is a neural network, there is some other probabilistic model, HMM and so on, that is all fixed once you train it. But this network, every instant of time, this architecture is changing. The architecture here is changing every instant of time. And it reconfigures itself to the task that is needed. See, that is the beauty of this whole thing. And why is it that it can never happen? Because you don't know how to do it. There's no algorithm that can ever be done to do this. See, that is why you can see, you can handle very fine things in a print. You can perceive very fine, small, short sounds in my speech or somebody else. Or if somebody makes a tap somewhere, suddenly you will perceive and so on. Or you can see a dark one, a thin line in a visual, this one. So these are all because of the dynamically reconfigurable neural network, biological neural networks that you have, which is the one that is helping to deal with the problems in cocktail party effect like this, and which is the one which you cannot, as of now, and also my feeling is in future, definitely not through the current technology. You see? That's what I want to highlight. Okay, so let us move further. I suppose this is now. What are the approaches for the detection and separation of sources? All said and done. Now, your source or a target signal or target speech is what you want to separate from a mixture signal, and also assume that most of the time either you mixed or the signal that you collected is mixed one and so on. Anyway, I discussed enough on this. So, what are the different approaches? For a long time, people like me working in signal processing, speech or acoustics and so on, we didn't have all these computation facilities. Even if they had, maybe a person like me may not have spent so much time worrying about how to use a computing power rather than trying to understand a problem. You see? So they're called the signal processing method. When I say signal speech, that mixed signal processing based method, exploiting the one good thing about all of this is talking about a speech signal produced by a speech production mechanism. So you can exploit the characteristic of a production mechanism that is called a signal processing based method to address the issue of separation of speech or separation of speakers and so on. And that's what we are doing from a mixed signal. So those are the methods at least I have worked with some of my students over the past 20, 25 years. In the last 4, 5 years, I'm not doing any of this. But then, of course, I will take there also. And that could be another very interesting I forgot to mention. Which will come anyway later or several times later. The point here is, when you go to a party, you hear that fellow, that person speak only that time. You never heard before, you may not hear later also. Is it? So you can't expect yourself to be trained to this one and so on to do this or that environment to do it. Doesn't work. It is only one time, one shot. That's all. Just as, for example, all of you are listening to me only for a first time, maybe the last time also, you may not hear me again. So the whole question here is, that is all that you have, and you have to process it. This is almost all the technique that have evolved more recently in the last 10 years. Use lot of data, lot of speech signals to do this. Where do we have that in the first place? And that even if we have, it is unrealistic. I suppose all of you get the point I'm making here, okay? And so, but if you have some, instead of production mechanism, signal processing method, there are also, if you have large enough data, there are what are called the stochastic or statistical methods. I don't want to spend time on that right now. It is only just to say that when you speak, your speech characteristics will have a certain, extracting some spectral features, whatever it is, they have a certain distribution different from the other speaker and hence other speaker. So because of the distribution variability that you have of the feature, what you might do is you might use that feature to separate the speakers. This is exactly what is done in speaker diarization and things like that. Those are called the statistical models and so on. Or you can also do the following ANN-based methods. Please note that this is not DNN. I want to distinguish between these two. ANN means artificial neural network-based model. What do you mean by that? That means a neural network model inspired by our limited understanding of the structure and functioning of the biological neural network, develop it for pattern processing application, and this you catch it as a pattern processing. That is what you are talking about. Of course, I can go on for several hours on that, but the point here is that was the way people worked from about 1986 to till about for 10, 15 years, till 2000 or something. You see? ANN-based methods. You see? Basically, what it means is it's a neural network, all right, with the 2 or 3 hidden layers and so on. And you can do a lot of fantastic things, but you design an architecture. Please understand why. You design an artificial neural network architecture inspired, of course, by the biological network and its functioning, to solve a particular pattern processing problem where speech and speaker separation is one such problem. That's what if time permits, I will show you a few examples of that. And then for the fourth approach, which is very prevalent in the last 10 years, is this one, DNN based, that is DL based. DNN is synonymous with DL. That means whatever learning you use in DNN, you call it DL. So that is the theme of this conference or what. So DL based. Notice fundamental difference between that and all other methods that are, of course, statistically slightly to some extent similar. DNN-based approaches are mostly data-driven approaches. You need large amount of data, hoping that there is some pattern which, and are including even feature these days, either feature extract and use the pattern among the features, or feature and pattern, both of them you extract using a large neural network that is called the deep neural networks and so on. And for that to use, you need most large amount of data. Data-driven, that is why. It's called data-driven network, but I call that as a technology-driven. Technology means if you didn't have these powerful machines, if you didn't have that much of data that is available and so on, and most importantly, if the scientific community didn't encourage you to do this evolution would not have taken place. You see? And this has taken place because of this, all right? But somewhere it will go on for some time. But unfortunately, the most of the cases, you also have seen papers and so on. Most of the data-driven approaches is what's called the black box. You don't understand what's going on, kind of a thing. That is why there is another field that is unfortunately emerging, is what is called explainable AI. You don't even understand AI. I don't know why you call explainable AI. In fact, it is a wrong word to use because you can't explain a black box at all. You see, or anybody can explain you depending on who is influential. You see, and so anyway, having said all of this, let's not discount or belittle the importance of this. He did some fantastic jobs, which I will hopefully I will be able to. And the last one, which I have listed, some people use it indirectly, but very little attempt is made. And is what's called the perception or knowledge base. Perception is the right word to use. And that is what is happening in real life as a human being. You see, it is the perception that is helping you to address these problems. You see, and it's amazing our human ability, both auditory, visual perception, and the neural networks, all integrated. It is not that they are separate parts and so on. And somehow I don't like a lot of people in my field talking about the auditory ear performs cochlea and this one, and it does band pass filtering and spectrum analysis. All that is, most of it is hand waving. I think there is much more to that, and all that is, as I told you, dynamically reconfigurable thing that is happening. It is not that even the operation of an auditory mechanism is not isolated, it's controlled by the internal mechanism dynamically. That's why if I'm talking, you appear to be listening, but you can shut off the auditory part and then think something else. You see, as though you have not heard about it. In fact, you can be deaf or you can be completely shut off your auditory mechanism by thinking about something else and so on. So it is a neural mechanism that is going to, so the perception-based approach. And when I write all of this, don't think that they are isolated. Each one has a merit. In fact, you have to understand all of them so that the real, I don't say solution, but at least advancement that can take place in this field might come by taking the advantage of each one of these, and because some of them may play a complementary role in providing a solution to you. See? So this is what I now. This is I'm already at 1 o'clock. Let me see. This is the one I don't know that you people heard about it or not. Why did we end up where we are? Why did we have to have a deep learning? And why this deep learning activity and let alone deep learning for speech and processing and so on? Why did we end up here? And now, of course, I will also give you in my 2 slides later what people talk about deep learning. And if you ask me, of course, you don't have to agree with me because some of you might have so committed to it, you don't like those words, but doesn't matter. But my impression, I am quoting from the literature, about half a dozen people talking about deep learning, including scientists, mathematicians, of course, technicians, technologists, and so on. None of them are correct. Not a single definition of what they have put is correct, unfortunately. You see, we will see that as we go along. First, let me quickly see if I can. This is a thing which I normally would love to spend about an hour, 2 hours or something, because most of you might have been exposed, but you want to see the evolution of this from how we ended up where we are, kind of a thing. I think I will not spend this slide alone, one single slide without switching another slide. I will need about 2-3 hours. So, but I will only spend 2-3 minutes on this. You see? So, what it is, you see, we talked about AI, and all that it is written here is AI related. You see, and all that is written in the black is kind of algorithms for that and so on. Now we are mixing up all of them and the algorithm itself is an AI and so on. That is unfortunate, but anyway, it's a, so anyway, quickly, I don't want to go through all these steps as I told you. And what happens is, as I told you in 50, when the AI term was introduced by John McCarthy and for the workshop at Dartmouth College. And so since then, the term stood, but its meaning changed. Its meaning changed. Its meaning initially, as I told you, the idea was to our understanding. That means you should understand every aspect of what human being is, the way he is doing, so that some of it or all of it can be simulated to demonstrate that you understood. That's all the purpose. But slowly it had changed. That for 1 or 2 decades later, it became what is called an engineering problem in the sense that whatever little that you understood, they say, that means, let us say, we say that playing a game, chess game is an intelligent part. So that part you want to simulate and show that aspect only. Please note that, not anything else, not in the chess playing, the intelligent part of chess playing, you want to simulate and show. That is how the AI thrived in 70s and so on. It is that's called the heuristic set. And then, of course, it went to then expert systems and so on. No, I don't want to go in. Then in our mid-80s, they said it's all not going anywhere kind of a thing, And there are a lot of disillusionment in that. In fact, I happened to be the chairman of the department. I set up a lab like expert system lab and so on, only to find out that it is not taking us anywhere kind of, And then suddenly this neural network called with a PDP volume, you might have heard that name, parallel distributed processor warning, that led to the field called artificial neural network. So for about 10 years, basically again, don't confuse biological network with artificial neural network and deep neural network with artificial neural networks are biological. They are very different. You see, these artificial neural networks, as I mentioned several times before today, is that it is a neural network model which will demonstrate, which is built or developed or evolved by our limited understanding of the structure and functioning of the biological neural network to demonstrate a few pattern processing abilities that we do. Just as we recognize human characters, handwritten characters, or we recognize, or we can automatically count the number of people in a room and so on. All these are by the pattern processing ability of a human being, and that is demonstrated by different. That means what is the solution there? Problem is there. That means pattern recognizing the characters in a handwritten character, handwriting or whatever it is. So you develop an architecture specifically for that task. There is no general architecture. So that means at that time, there are hundreds of neural network architectures addressing different pattern processing tasks and so on. Please note that is called a pattern processing. But then what happened is the computer power was increasing, and that shifted the attention of this artificial neural. That's why after 96, 97, very few people talked about artificial neural networks. You see, also nobody talked about artificial intelligence. From 1986 to 2000 nearly, artificial intelligence was dormant. In fact, if you talk about it, you are looked upon as you don't belong to this society kind of a thing. Why? Because the computing power is increasing, data was increasing, it was a machine learning was the one that was, and machine learning has nothing to do with neural network. You see? And anyway, I don't have time to go into all of this. Supervised, unsupervised, reinforcement. And then what happened is 10 years later, that was in 2006, around that time. And because it requires a little bit more understanding of the evolution of neural network. But anyway, there is almost a breakthrough idea kind of a thing. Just I will not tell the breakthrough itself, but I will tell you the logic behind that, why it is so. As a human being, you see, we don't do classification. Or we don't do, suppose some 3 or 4 people come to my office, let us say. The first thing that strikes you is how different they are. one is taller, one is this one is this one, like that, you call contrasting, that is a classification. The featured parameters that you use to discriminate, that is called a discriminative part of it. But if only one student comes at a time, let us say your student or your colleague frequently, then what is it that you do? You find the descriptive part of that person. So discriminative learning and descriptive learning, there are neural network models for that. Discriminative learning is a multi-layer perceptron. Discriminative discriminative learning, descriptive. Descriptive learning is feedback network, and it is also called the Boltzmann machine. So it is a Boltzmann machine. So as a human being, see, we use both of them. And without, so it is that combination. In fact, that helped Hinton to come up with an idea. How do you combine both of them instead of just all the time talking about disco classification or regression on one side using a feed-forward network, or in terms of description like a pattern. So how to combine? That is where the correct term deep learning was introduced. You see, deep learning simply means a combination of descriptive learning and a discriminative learning. Together is called the deep learning. And what you are talking today, deep learning, is nothing to do with deep learning. Please note that. In fact, that is a wrong word, but we have to go with that because everybody calls, Nehru as Gandhi. So you call also Nehru as Gandhi, like that here also. If everybody calls deep learning, so you also call deep learning. Otherwise, that is the deep learning. And there is a concept of restricted Boltzmann machine and so on. Anyway, all that. So it was that was introduced around 2006. For about 3-4 years, it prevailed, and this word, it is fantastic. Of course, the descriptive learning part, they segregated a little bit. First, your descriptive learning, pre-training, use that as a pre-training to learn to train a discriminative deep network, means large number of layers of neural network for classification. That is what very fantastic results have come and so on. There's no question. But then what happened? Then what happened is around 2000 onwards, 2012 in particular, what happened was, okay, don't struggle with all of the descriptive and pre-training and this one. Use a large network. Large, what was earlier large, the network was only 3 layers, 2 layers and so on. Very small number of parameters, maybe a few thousands and so on. Instead, make about 50 to 100 layers or something, and the number of parameters, that means weights will be 1 million, 2 million. I even heard that the people created networks with 1 billion parameters and so on, all kinds of things like that. So that is what is called the deep neural network. If we have that, they claim that pre-training is not required, and hence that is where the origin of deep neural networks came. And if we have so many parameters to be determined, then what is it that you have to do? If you have so many parameters to be determined, you need also data. So it is not enough if you have 1 minute data, 2 minute data of speech, let us say. You need hundreds of hours of speech to determine those parameters. That's why they become data driven. But having said that, there is computing power is there, data is available, and so they could also produce fantastic results. But please note that I don't have time to discuss DNN is nothing to do with neural networks. Nothing. It has not even a distant relation to neural networks, although it is called deep neural networks. Deep learning has nothing to do with the learning of a neural network. The deep word has nothing. In fact, deep learning and DNA, the learning is all shallow. It is not deep. Only thing is, since you are using a deep neural network for using a supervised learning algorithm like backpropagation, it's called deep learning. So please note that that is the correct way of saying. A lot of people may not know, or even if they know, they were skirty. But and the network itself that you are talking about, I will show you probably in the next slide. This is a slide I don't want to read all of them, but some of these are taken from the technical papers from experts. You see, it's not from an ordinary people or students, and I have not defined. Deep learning is an AI function that mimics the working of human brain in processing data for use in detecting objects, recognizing speech, translating language, making decisions. All bogus. It's wrong. Not a single word in that is correct. First of all, there is nothing like a neural network in a deep neural network. None of the features of neural network, the neuron model itself is wrong. Rectified linear unit that you use to avoid the this one gradient what do you call it? Yeah, I forgot the name. It is rectified linear has nothing to do with neural network. I only wish you had a 1 or 2 hour lecture on neural network itself in this course. Then you would have appreciated some of this, you see, and so on. Anyway, I don't want to go into all of this. And so basically, again, at the same time, you can't go away from the rest of the community. You know? You still use the deep learning, but you make sure that this is not the deep learning which was originally introduced, and this has nothing to do with a neural network. Nothing to do with even artificial neural network. What to talk about biological neural network? No. And but although everybody says it mimics and so on and so forth and so on, and they say that's why whatever you do with the deep learning is called AI, and another AI has nothing to do with deep learning. See, be careful. Again, I am not saying that you should not use it. You have to move with the crowd, so you use it. Because all scientific AI and machine learning, everywhere, every college, every university, including IIT, they have a big program. But the tragedy is, unfortunately, they called it AI anyway. They didn't call it. It had nothing to do with AI that was intended. It's a technology-driven AI. Whereas the original AI is a science. See? So anyway, now I think I have. So deep learning, DNN-based deep learning approaches for speakers, they basically, you might have by now, you have not only heard, you might be using already the MLP, or MLP itself is a wrong word, unfortunately, because you never use MLP, and it is not multi-layer perceptron. It is called a multi-layer feed-forward neural network. You never use the word, use perceptron model at all in any of the current networks. Anyway, I need at least a couple of hours to explain that point. But so the multi-layer perceptron and multi-layer feed-forward neural network is one neural type of DNA. That means you have a large number of layers and large number of weights and so on. And then you have what is called the CNN, convolutional neural networks. Basically, it is some special case of this where you try to extract the local features and so on. You have a combination of convolutional layers and a subsampling layer and so on. You have a large number of them to accomplish many of the tasks. That's called a DNA. And since both of them are feed-forward type of a thing, and you will not be able to capture the patterns in a time sequence. See, whereas speech, video, all of them are patterns. The pattern is not in the frame or in the segment, but it's in the sequence. So the temporal pattern is captured, cannot be captured well by a MLP or CNN. So they use what is called the recurrent neural network. And recurrent means basically what it means is each hidden unit output, you feed them back. There is a feedback layer and so on. It is a recurrent. Of course, there are hundreds of varieties, dozens of varieties, LSTM, BiLSTM, and so on and so forth. And then what you have is also, the what is called the GAN. That is generative adversarial network. Of course, I don't know much about, but I would allow to talk about its implications there, but anyway, I don't have time to do it. And then, of course, the idea of autoencoders, decoders. What it simply means is you have the input, you map it to itself, and whatever is there in the compressed layer, you take it as a feature and so on. So these are all the various types of DNN, and they are used, I have described them here, they are used to develop many applications in speech and so on. You see, each of the slides that I am displaying, unfortunately, I just even without switching the slide, takes about couple of hours. So I'm just doing it in a few minutes and so on. Okay, let us focus on this deep learning method for speech separation. It is basically a supervised learning. That means you map this whole speech separation problem as a deep supervised learning problem with a large network. That means large number of layers and so on. By now you know what I mean. DNN. And so in order to use that, or in order to determine it, you need large amount of data. You see, and the target, what is the target? Any data, it is supervised learning means what is that supervised? What is the desired output kind of a thing? Desired output can vary, of course. The most important thing here is time frequency indicate context of speeches. It's called time frequency binary mask. You create a time frequency binary mask, that is the desired output. So that if you have mixed signal, that is you have a 2 or 3 speaker mixed signal. For a given speaker, you create a mask, ideal mask, and then train a network to extract the speaker. And then next time when you give another utterance of the speaker, it will bring that mask and so on. It is not enough. If you type time, what do you mean by time frequency mask? In time, you divide to several instants, and then frequency divide to several frequency bands and so on. And each of the grid for a given speaker, only a few of those will be active, all others will be zero, set to zero. And for another speaker, the assumption is that you will need another binary mask and so on. And surprisingly, using that and the mixed signal TF represent time frequency representation, you put that mask and then resynthesize. For synthesizing, of course, most of the time you use the what you call the all this is done in a speech or spectrogram. So you use the noisy signal phase and that masked spectrogram to resynthesize. That is the general principle for speech separation or speaker separation. And there are many, I am not going to discuss all the detail. I think I will leave this. And now I want to see if I can conclude and show at least 1 or 2 demos. I have about 20, 30 demos, but I will show 1 or 2. And so what is important here is always let us keep, that's why I always ask my students, of course, obviously they don't follow my instruction fully. What can you do? The point here is, I said don't use any time a canned data. That means collected data. You develop something, you should see for a practical data, even if it doesn't work, doesn't matter, so that you know what are the limitations of it. The moment you have the canned data, all these challenges that people project and so on, I mean, that is all nice, somebody has computing power, somebody wants to show he is better than others and so on. All that is fine, but unfortunately, they don't yield anything useful for practical data. In a few cases, maybe, but unfortunately, no. And also, I have and also very interesting thing. You see, when deep learning came, you need large amount of data training and so on. Actually, personally, if you ask me, in particular, I spent in the speech area for about 50 years now. I spent almost 2-3 decades to understand 1 second of speech. So even now, I don't understand. Although I produce about 30 PhDs to understand 1 second of speech. So now we process 100 words of speech in 10 minutes. What does it mean? The difference is you don't understand what you're processing because you don't know. So, but at the same time, it's not that you should not do. Please let me not give a wrong impression on it. You have complementary nature of this. You should take advantage of both. That's all the point I'm saying. It is not that by the processing 100 hours of speech, you have understood speech better. Or you can live only with the processing 1 second of speech and so on. And there are many other things I think I don't have and the most difficult thing here is targets are not available in supervised learning for you to use. And also if the problem and solution is clear, then you can find a method or architecture to, if it is not clear, that means people process speech signal differently. So which one you want to implement? That is the problem we face. So I think I will stop with this and then I will show at least some 1 or 2 slides, if not many. I would think I will project this references. My paper is the first one I have listed, is the latest one I have not read yet, but I think it's a very, very useful article for me. And the rest of them, in fact, all my presentation of deep learning method, I have not really shown any of them. I wanted to show, but they are produced. Most of these studies are done by a group by Dilian Wang, Ohio State University. They're done a fantastic job. There's no question about it. Excellent results are there. And more recently, of course, this Nima Mascarani is a professor at Columbia. His group is doing fantastic job. See, and they are working on using end-to-end solutions instead of extracting features from feed. They are using what we call the waveform to do this and so on. And because some of the early work that we did, not early, more recent also, we did the name, not neural network. Neural network also we did, but not deep neural network. And we have some success, got a lot of failure also in this. And these are some of those. Of course, I have at least about 30, 40 papers. And because of deep learning based on, there are about a few hundred papers. And you can't read all of them, and I don't advise you to read also. Okay. So I think with this, I will close and then see if I can play at least one or two demos. I am not very sure. Unfortunately, the situation is like this. Without explanation, if I play, it makes no sense. But all the same, I will just do that. That's all. I think. Can all of you see this slide?
Yes, yes.
Okay. So what I'm playing here, this is very simple. The first 50, most of the demos are what from my lab. I don't have a lab anymore now, but till when I was working. So it's all work done in the last 15, 20 years kind of a thing. And the first one is a very simple practical data. Whatever I show, they are practical, real data collected in a real room, no synthetic this one at all. So basically a signal like this, if it is given, I suppose, can you hear? All of you? Can you hear the audio? Nobody has to respond.
Yes, yes.
Yes, sir. Yes.
Yeah, I can't hear your response.
Yes, sir.
Good. Okay. So if you can hear, that is a noise speak, single channel, only one microphone. And I didn't use them, just using some speech properties, that is voice and voice and things like that, And so this is the. So it is not a great performance, but basically reducing the effect of noise and improving it. And so this is another example, but I don't want to spend all of that time. Maybe let me see what. I suppose you recognize his voice because his talk you heard in the yesterday or day before, I don't know. Do you know who it is? Come on. You heard his talk, in this workshop. Have you heard his talk already? No?
So it is not audible.
I am not audible.
This voice is not coming.
Oh, my voice is not coming.
No.
We can hear you, sir, but that voice we are not able to hear.
Oh, this voice. Okay.
Yes, sir.
You can't hear? Now I know what to do. Okay. I got it. You see, apparently when I play this, I should mute my mic. So did you hear?
No, sir.
No, sir.
No, sir.
No, sir.
Huh?
Sir.
I'm not. You can't hear anything at all?
No, sir. We can't hear anything.
No, sir.
then what do I do? I think I tested before. It was okay.
The previous one came, but this one is only not coming.
Oh, acha. Okay, let us go to the next one and see if you can hear that. I don't know whether there's any problem. This. Did you hear this? No? Yes or no?
No.
No, sir.
No,
Sir, it
sir.
was not audible.
I think there may be a problem then. I don't know how to handle that. But anyway, doesn't matter. I think I will have to stop at this point. Basically, there are a number of illustrations to show. Some of them are simply signal processing based. Some of them are ANN based. That is what we have been working on. And the DNN based one also I have put it, but they are not my work. It is a work from a Dina Wang's group from Ohio State University. They are excellent. I mean, that is the one that encourages you to think that deep neural learning can help in, separating the speech mixtures, speaker mixtures, and so on. And those illustrations are wonderful. Wonderful, not only wonderful, I think they have evolved it over a period of almost 7-8 years, and they are doing still work on it. And I think the success of deep learning can easily be seen through those illustrations. But having said that, as I told you, I'm a researcher. I want to really find out how well they can do with more complications or for a practical data and so on. That is the challenge of all of you have to face. I think we will have to, let me see what I should do. Okay, I think. So I have a lot of illustrations, but I don't think I have time to do these things. You see. So let me just to give you if all of you can see the diagram, can all of you see the diagram?
Yes, sir.
Yes or no?
Yes, sir.
Yes,
So
sir.
just to give you an idea, you see, this is a target speech kind of a thing. This is the intrusion, maybe some other speaker noise. So these two are mixed, and this is a spectrogram. By now you know what it is. So this is a mixture of this. And what is done here is you create a mask by the neural network using deep neural network, and that is ones and zeros in this, and you mask this over this. That's what it is, masked mixture. You can see the black one is masked in this. So the resulting you play, you will get a fantastic separation and so on. I don't think you can hear, but if you can't hear, I can, unfortunately I can. So this illustrates the basic idea of deep learning applied to speech. That is, you train the network using a target of time frequency mark, and then test it with a new situation. Of course, there are hundreds of issues on this, and I don't have time to explain that. I think we have to close at this point, and I'm sorry for many things here, which is okay. This is the summary and conclusions which I have put earlier, and same thing applied. So basically, the purpose of my talk here is not to tell how great certain things are, we did or somebody did or something, or how great neural network or deep neural network, deep learning can help and so on. To tell you what needs to be done, and how to look at a problem. Because you have another 30, 40 years of career in front of you. So you should look at the future, what it is, rather than the present. At the same time, you should learn what is going on, but don't put all the eggs in that basket. Don't think that that is the way to go. After 5 years, this may disappear and something will come. But the problem remains. Cocktail party problem, speech separation problem, and the more general sound event detection problem. It's a challenging problem, and it requires a lot of ideas, new ideas, and so on. That is what I wanted to look at. And also, if your time permits, you try to read some of those articles and that references that I give. I think I will stop at this point because it's not Thank you very much for your kind attention. I'll be happy to respond if
Very
they.
much for the motivational talk.
I can't hear.
Now, sir, can you hear me?
I can't hear, madam. So, no, who is speaking? I don't know. Can
Sir,
you?
can you hear me? Hello?
Yeah, now I can hear. Yes. Please,
Yeah. Sorry for the inconvenience.
Yeah, please go ahead.
Thank you for the motivation. Now I request the participants to ask the doubt if they have any.
Sure. You're welcome to ask anything. I may not be able to answer everything, but
Hello, sir.
Yes.
I'm audible. Yes. So my question is, when we record the speech for the experiment, we use most of the time stereo channel for recording. And
Okay.
when we go for training the ASR or any problem related to speech, then we select for the mono channel. Then why we are not recording in mono channel?
Actually, most of the studies that are made for the deep learning is only mono channel. You see, but two channel or multi channel also is available, but in practice it may be difficult. That's all. You see, that is another study altogether. Binaural, two channel or multi microphone. See, ideally the problem I have in my mind is suppose like you put microphones all over in a room. You collect that. And can you use that to isolate, locate the speech? In fact, some such studies are made, but they are not very successful in most journals, but they are okay. MIT started a project, $55 million project, and closed it down. And I think it is called Oxygen Project or something. I don't know. But, anyway, your question is, yes, two channel. In fact, two channel is better. Two or more channel. You can have additional information, that is spatial information, which can help you to separate this. In fact, I have some demo. Maybe look at some of our papers and so on. You will get an idea on that. You see, and okay, does it partially respond to your question? I hope so. Yeah. Anybody else, please?
Yeah, hello sir. Am I audible?
Yes, please. You are.
Yes, sir. So my question is, sir, this type of raw data are difficult for training. Like we cannot able to extract the features correctly. So
Can you repeat once again? I think your voice is breaking. Yeah, please repeat. That's all.
so this type of raw data, am I audible now?
Yeah, you are audible.
Yes, recorded in this means normal room environment. These are very difficult for training. Like we without feature extraction. Feature extraction become difficult.
Yes, you're right. You're right.
So is it means we have to pre-processes like SNR means we have to reduce the SNR. So somehow it's very difficult in that way. So
It's
is
a
it a
good
good way
question.
for the training? Should this data be training so that it?
I get the point. You see,
Yes, sir.
what you are basically saying is real data, it is difficult to extract features and so on. You see?
Yes, sir.
Which you need to feed an input to the network or whatever it is, you see. But what is happening, more recent trend in the last 2-3 years, is what you call another approach is end-to-end solution. That means you feed the waveforms, okay, directly, and there is a layer in last but one, and you call that as an embedded feature. You take the output of that as an embedded feature, use that as a feature for all the time, frequency, mask estimation, and so on. That is one approach. And there are very recent papers about 2020 and 2021, and some of them I have listed here. And you can refer to them very easily. Wave end-to-end solution, but there is a lot of catch there. You see, they use large convolutional neural networks and so on, and there is a problem there. You see, the problem, to simplify the problem, is the following. You see, no matter whether you use a waveform or a feature, you have to use some segment. If it is a 20 millisecond, 100 millisecond, 200 milliseconds, you cannot do entire 1 minute speech at one stroke, you see. And you cannot also do. So what is happening is, suppose you are given 100 millisecond speech segment, even human being cannot recognize. You see. So that handling of a temporal pattern, the way human being does, so far no machine can do it. See? You follow what I'm saying?
Yes, sir.
So that is a challenge. I think your question is very well, but having said that, we have to keep struggling. We have to keep figuring out how to represent this. Representation itself is a problem.
Right, sir.
Okay? And that don't take that the problem is hard. In fact, it is a gold mine of opportunity. A lot of work can be done. Keep yourself busy for next 30 years. Yeah.
Yes, sir. Thank you.
Yeah. Yes, please. Somebody has a question. Raise his hand.
Sir, I have one basic question, sir.
Please.
Sir, what is the difference between the audio signal, audio processing and speech processing? Actually, I'm from this area. The question may be.
Yeah, the difference, very good point. Maybe I didn't clarify it. The audio means any signal that you see. Let us say birds chirping or dog barking or something else, or motor sound that you get, automobile sound. That all along with speech, that is audio. It's a more general. Whereas speech is a more specific one. You see, produced by a speech production mechanism. So, if you ask me, speech processing is a little easier, relatively speaking, because there is a certain characteristic, although you don't know how to extract it, certain characteristics are there because you have some small knowledge of production mechanism.
Yeah.
Which you should be able to exploit in developing an algorithm.
Yeah. Thank you, sir, for clarification.
General.
Yes.
Okay.
So the speech processing can be said as a subset of audio processing.
Beg your pardon?
The speech processing is the subset of the audio processing.
Yes and no. There is a big difference. You have to be very careful. Speech processing for what purpose? Depending on that, you have to. If speech processing is what you want to, in that you want to recognize a speaker, or you want to recognize the sound of the message that is conveyed, it's a totally different. For example, if it is a dog barking, you are not looking for any message there.
Okay.
You see, so speech processing that way is not a subject. It is a much more wider subject.
Yeah. Thank
Is
you,
that the
sir.
point I'm saying?
Yeah. Thanks.
Any other questions?
Sir, I think one question is there in the chat box, sir.
Chat box. I don't know how.
Yeah. Sir, I can read the question.
Just please read it if you don't mind.
Yeah. Many people work with CNN for audio classification. But as you said, the information for audio is in temporal sequence. So should we go for RNN rather than CNN?
Actually, of course, it requires a lot of explanation kind of a thing. But the point here is, you can do both. You see, you can do both, but you need a long data. That's all. More, almost 10,000 samples or something like that. Input this one. Then you can do directly this speech. You have all the context and so on. You see, or of course, the people are using both, and so it depends on the task. If you are separating the speaker, there are many issues here, but you do it segment-wise and recombine them. That means cluster them depending on which segment belongs to speaker and so on. So that is what is being done. But having said that, your question is very much valid. Don't worry about CNN and DNN and so on and so forth. You see, CNN, if you have, let's say, 1,000 or 10,000 dimensional input vector kind of a thing. What is right? You see, that's not a big issue at all. You see, in fact, a more recent article by Massagamani, and he used some system, you see, large network, CNN network, to do the temporal processing of this, you see, because there's a lot of problem with RNN. Is it recurring neural networks and so on? Is it that is a although they show some success, but I think its use is a lot more limited than DNN implemented through CNN. You see, although CNN itself has a lot of problems. If you want to type it on Google, Hinton wrote a article in Nature, I think, what is wrong with the CNN. You see, so I mean, there are hundreds of articles these days. You see. So all of them you should take them with a pinch of salt. You see, because you are a scientist, you are a businessman. You should say that solves everything. But if you are a researcher, always look at it with skepticism. That way, your question is right. You see, okay.
I think there is no more question. So,
please.
thank you, sir. And sir, please allow me to introduce.
I think you have to take out your mask or something if you are talking with a mask.
No mask here, because of the network problem, sir, you may not able to hear. Sir, just please allow me to introduce myself. Sir, I am the assistant professor over in IIT Patna, and I am the student of Professor Rajesh Hegde.
Rajesh Hegde, you were our student, yeah.
Yeah, so I know you, sir, since
I was not my student, my student.
Yes.
Yeah, tell me.
No, sir, just I wanted to introduce, sir.
Yeah, he is very great, you know.
Yeah. So I know your work, sir, since although I have not worked in the speech processing, although my supervisor was Professor Rajesh Hegde, but I work in the wireless network, signal processing.
I know.
I know you since that time, sir, since 2010.
Yeah, I have not changed my field. I work in signal processing, in speech processing in particular.
Yeah, and recently the deep learning has been, and after that the deep learning has been introduced. After 2010.
Good.
So, sir, I would like to thank you, sir, for accepting the invitation and delivering such a nice talk in the short-term course at IIT Patna. And it is a more the effort has been come from this Dr. Udit and Dr. Saurabh Kumar Pandey, who are the organizer of this course.
Thank you.
Thank you very much, sir, for this talk. So I think now we can stop this session. So participants will meet in tomorrow's session at 10 a.m. So the session is closed for today. Thank you so very much, sir.
Okay, thank you.
Shall I close, sir?
Yeah, we will close.
Okay. Bye.